Hello students, welcome to the lecture of Basic Concepts of Chemistry. In the last lecture, we had discussed about the average atomic mass and we had solved some numericals. Today, before starting some new chapter, we will do some more numericals on average atomic mass and then we will go on with molecules and molecular masses. So, let's start. So, there is one question from average atomic mass. The question is, magnesium has 3 isotopes, Mg24, Mg25, Mg26. We have to find the average atomic mass. So, the mass in AMU and percentage of abundance are given like Mg24 has a mass of 24.00 AMU and abundance is 78.99%. Mg25 has a mass of 25.00 AMU and an abundance of 10.00%. Mg26 has a mass of 26.00 AMU and a percentage of 11.01%. With these informations, we have to calculate the average atomic mass of magnesium. So, if we say the average atomic mass is this, M average, then what is the formula that we had learnt in the last class? That is, the mass of each isotope multiplied by its percentage and divided by 100. So, there are 3 isotopes. So, we will have 3 expressions, M1x1 by 100 plus M2x2 by 100 plus M3x3 by 100. Okay. So, let's put the values. M1 is 24 into x1 is 78.99 divided by 100 plus M2 is this 25 into this is x2 10 divided by 100 plus M3 is 26, 11.01 is x3 divided by 100. So, this comes as M average equal to, so we can write 24 into 0.7899 plus 25 into 0.1 plus 26 into 0.1101. Okay. So, this will come as 18.9576 plus 2.5 plus 2.8626. If we add these terms, then we get the final result as 24.32 AMU. Since all the masses were given in AMU, and percentage is dimensionless. So the average atomic mass will come as 24.32 AMU. So average atomic mass of magnesium is 24.32 AMU. We will see one more question. So the second question is, boron 10 and boron 11 has average atomic mass of 10.8 AMU. Find the percentages of each isotope. Okay. So boron 10 and boron 11 has average atomic mass of 10.8 AMU. Find the percentages of each isotope. So here average atomic mass is given, we have to find the percentages. So let's assume percentage of B10 is equal to X. We know that if we add the percentages, it becomes 100, right? So if the percentage of B10 is X, then percentage of B11 will be 100 minus X. Okay. So according to the formula, M1x1 by 100 plus M2x2 by 100, right? So what is M1? M1 is 10 and its percentage x1 is X. So 10 into X by 100 plus M2 is 11. 11 into the percentage is 100 minus X for this isotope by 100 is equal to the average atomic mass that is given, that is 10.8 AMU. This is equal to 10.8 AMU. Okay. So if we solve, then 10x by 100 plus 11 into 100, that is 1100, minus 11x divided by 100 is equal to 10.8. So we will take this denominator of 100 as common and we can write as 10x plus 1100 minus 11x is equal to 10.8 into 100. So 10x minus 11x is equal to 1080 minus 1100. Okay. So minus x is equal to minus 20. So we cancel the minus and we get x equal to 20%. So x is whose percentage? X is the percentage of B10. So percentage of B10 is equal to 20% and percentage of B11 is 100 minus x, that is 100 minus 20. So the percentage of B11 is 80%. So these were the numericals based on average atomic mass. Now we will study about molecules and molecular mass. So what are molecules? Molecules are made of different atoms. So different atoms of the same or different elements come together to form molecules. So molecules can be formed by various kinds of bonds. Okay. So for example, let's say water molecule H2O is made up of 2 atoms of hydrogen and 1 atom of oxygen. One methane molecule is formed of 1 atom of carbon and 4 atoms of hydrogen. Similarly, one molecule of ammonia is made up of 1 atom of nitrogen and 3 atoms of hydrogen. So, since the atoms have a definite mass, so molecules will also have mass. So now that we have learned about calculating atomic masses, we need to learn how to calculate the molecular masses. So, we will start with molecules. So, a molecule is an electrically neutral group of 2 or more atoms held together by chemical bonds. Okay. So, a molecule is an electrically neutral group of 2 or more atoms held together by chemical bonds. So, for example, 2 atoms of hydrogen form H2, 2 atoms of chlorine form Cl2, 2 atoms of hydrogen and 1 atom of oxygen form H2O, 1 atom of nitrogen and 3 atoms of hydrogen form NH3, 1 atom of carbon and 2 atoms of oxygen form CO2. Okay. So, these are some bond formations to form molecules from atoms. So, what is the molecular mass or molecular weight? So, molecular mass or molecular weight is the mass of a molecule. This is very clear from the term itself. Now, how do we calculate the molecular mass? So, molecular mass is the sum of atomic masses of the elements present in a molecule. Okay. So, molecular mass is the sum of atomic masses of the elements present in a molecule. So, what we have to do? So, we will have to multiply the atomic mass of each element with the number of that atom present in the molecule. Okay. So, we will have to multiply the atomic mass of each element with the number of that element present in the molecule. So, let us say if we have a compound AX, BY, CZ, okay, then if this is the molecule, how will we find out the molecular mass? Let us say A has an atomic mass Ma, B has an atomic mass Mb, and C has an atomic mass Mc. So, and there are X atoms of A, Y atoms of B, and Z atoms of C present in this molecule. So, we will calculate the molecular mass as Ma multiplied to X, that is the mass of A, atomic mass of A multiplied into the number of atoms of A, plus atomic mass of B multiplied with the number of atoms of B, plus atomic mass of C multiplied by the number of atoms of C. So, we get this as the molecular mass of this molecule AXBYCZ. So, the molecular mass is XMA plus YMB plus ZMC. Okay. So, this is the molecular mass. For example, we have the methane molecule. Okay. So, the molecular mass of methane will be equal to atomic mass of carbon into number of carbon plus atomic mass of hydrogen into the number of hydrogen. So, atomic mass of carbon is 12 into 1, that is 1 carbon is present, plus atomic mass of hydrogen is 1 into 4 hydrogens are present. So, 4. So, 12 plus 4, that is 16. So, this is the molecular mass of methane. Now, what will be the unit of molecular mass? Since the atomic mass is measured in AMU, so molecular mass will also be in AMU. Okay. So, now if we talk about water. So, molecular mass of water is equal to atomic mass of hydrogen, that is 1, let us say mH, into number of H, okay, plus mass of oxygen into number of oxygen. So, 1 into 2 hydrogen. So, 2 plus 16 into 1. So, 2 plus 16 equal to 18 AMU. So, this was the discussion for the molecular mass. We will study more examples on calculating molecular mass, and we will also learn about formula mass in the next lecture. Thank you.